Hey, welcome back. I got on my bench today, I got a Pioneer SX-315. Now this looks like a audio video receiver, but it's actually just an audio receiver. It has no video components to it, no video components in the back, none in the front, but it is a good receiver for audio, digital sound. It's got a built-in DAC. It's 96 kilohertz, 24-bit DAC. On the digital side of things, we can input from different digital inputs. We have two inputs on the back, TV and a tape and VCR. It's got a built-in AM/FM tuner, and not much else to it. It's got a bunch of buttons that don't make sense, and just a main volume. So I picked this up the other day as part of a lot. I bought 3 receivers for a pretty good price, and I believe this receiver was the one that was in working condition. The other 2 have problems with right or left channel. I can't remember. I'm going to go through them after this, but this is the one that works. So I just took it out and I was checking things out. I took a look at the DC bias adjustments for the 6 amplifiers, and they were all within spec. I pulled out the power supply board and I checked for crack solder joints, and I didn't find anything. Checked a few ESR on the caps, everything looks good. So this is a low hours unit. It hasn't seen a lot of use, and it's still got a lot of life left in it, even though it's limited in what it can do. Like I said, it's got no video component, it's got no HDMI, it's got no composite video, but it does have some nice features, for like an amplifier that you want to use for whatever purpose. You want to run TV or stereo. So there's really no repair on this one. I was just taking a look at it, and I thought I'd just turn on the cameras just to show you a little bit about it. The display's kind of dim. I don't know, I don't think it's anything to worry about. It's not as bright as it should be, I think. It is 15 years old, but like I said, I don't think it's seen a lot of use. The probably what I'll do is I'll just after checking it out, I'll just put it all back together. And what I'll do is maybe I could use this as a giveaway on my channel for all my viewers, and maybe I'll do a contest. I was thinking maybe when I hit 1,000 subscribers, I'll do a giveaway. I know I got a long ways to go for 1,000 subscribers, because last time I checked I was at 33. Even though I started off the channel at the beginning of the year, halfway through the year I got 33 subscribers. I hope that number climbs. But I'm thinking I'll do a giveaway, maybe one of these, if people are interested. I can do this receiver. It won't be cheap for me to ship across North America, but hey, why not? But yeah, I just wanted to turn the camera on and give this a check out. Not much else to say about it. I went through the idle adjustments, and it was all good. I think I adjusted 1 channel out of all the 6. And as far as I can tell, everything's working 100%. I didn't check all the functions. I could go through and check them. I see no reason why it wouldn't work. But I'll give it a complete going over. So let's have a little tour of the inside of this receiver. Let's start with the power transformer. It's not overly impressive. I don't think you'll get 600 watts of amplifier power out of this thing. I don't think it's rated for that amount, to tell you the truth. It's not the biggest transformer I've seen, and it's not the smallest either, but I doubt this is able to do 600 watts or 100 watts times 6 channels. There's a power supply board here. Let me turn the power off here so I don't electrocute myself. Power supply board here. It's got your standby power for the remote and the microprocessor, and then we have some regulated supplies, plus 5 volts, I'm guessing, and then I think these are I'm not sure, maybe plus minus 15, who knows. And then onto the main board, we have our outputs on this side, and there's 4 relays. One of the relays is for headphone jack, I understand. You got these 2 little tiny 6800 microfarad 50 volt capacitors for the main power supply, and these 2 little tiny bridge rectifiers. I guess they're rated and they're okay, but you know, down here there is the protection board. This little circuit here handles the protection circuit, and then here we have the main amplifier. We got left channel, right channel, front right, and then we got surround left, center channel, surround right, and front left channel. And then this board up here is for the subwoofer. So there's 6 amplifiers here in this assembly. Big massive heatsink. It looks like it's about 12 inches long. It's a good chunky one. And then on the back of the front panel we have our microprocessor and all of the display electronics, all the buttons, all that goodness there. And then I'll flip you around to the other side. On the other side of the heatsink we have our tuner, AM/FM tuner. It's just a little module, and that's its connection to the outside world, or the inside world I should say. This board here is strictly digital audio converter for the audio, and input selector, and optical input, coaxial input, and this handles all the the digital to analog conversion for the power amplifiers. Not much else to say here. I'll show you the back panel. Back panel is pretty sparse. Power input. There's no courtesy outlets. Speaker connectors for 6 channels. You got your 2 front, your 2 surround, subwoofer, and center speaker. AM/FM input. You got AM loop antenna and FM coaxial. Digital inputs. You got optical and coaxial. And then these are your inputs for audio. You got an input for TV in, which would be your auxiliary, I guess, if you had nothing else to use. And then you have an input for tape or VCR, input-output. So there's actually only 2 inputs and 1 output. Got a wireless output here for wireless speakers. I believe that's what it's for. Yeah, it's not much. And I don't know if you can read this. November 2005, so that's when it was built. So it's 15 years old. Okay, so I was looking at the spec sheet for this receiver, and it looks pretty impressive, I'll tell you. Here we got, I'll show it to you, if you can read it. Front, it says the front we have 100 watts per channel. And then down below, keep going down, it says RMS power output, 125 watts, I think it says. Is that what it says? Oh yeah, 125 watts. And keep going down, the bullshit gets more and more. Music power output, 167 watts per channel. I'm thinking, wow, that's some pretty good numbers that they can print on their own equipment. Now they got little asterisks here. It says measured pursuant to the Federal Trade Commission's Trade Regulation Rule on Power Output Claims for Amplifiers. And so I guess they have 100 watts per channel. I guess it's allowed to BS. But yeah, this is into 6 ohms. I forgot to mention that. That's into 6 ohms. So that might actually happen. I don't know. But I got on an 8 ohm mode here, and I'm not getting anywhere close to that. So let's do a little power test. I got the receiver all hooked up, got it on the scope, the outputs, and I got the RMS voltmeter hooked up so we can measure exactly what this thing's putting out. And turn it up. I'm feeding it 1,000 hertz signal, and as I crank it up, you can see on the scope, here it comes. This is the front left, front right channel. Okay. We still have 4 other channels I'm not using, so I'll just keep turning this up, turning it up, and then I hit it. See, one thing I don't like about these digital volume controls is you have really no definite. See, you either got this step, or this step, or this step, and there's no in-betweens. So you just keep going up step by step, and there's it clipping. I take it back 1 step to where I get a clean signal, and I'm measuring 23.15 volts RMS on an 8 ohm load. But yeah, it's, I don't know. I'll just let this cook for a while and see how hot it gets. It's got a massive heatsink. It's got the no fan. It shouldn't need a fan. It's got a good heatsink. It's got lots of ventilation. But this spec, 100 watts per channel, 200 hertz to 20 kilohertz, 1% THD. And down here, these other ones, RMS power output, 125 watts per channel, 1 kilohertz, THD 10%, 10% distortion. So we're well into clipping area there at 10%. I would guess if I hit this button one more time, that's your 10% there. You can see it's clipping. And I'm only getting 25 volts even out of the into an 8 ohm load. But I don't see how they're getting this music power output, 167 watts per channel. That's DIN at 10% distortion, 6 ohm load. Just doesn't make sense to me. And I don't think it's possible. But they can claim whatever they want, I guess. So before I started videoing this, I had the amp on maximum output, and then I walked out of the room for a while. I forgot about it. And I came back in, and the room had a kind of a warm amplifier smell. So I immediately turned it down. It was actually doing pretty good. It's not, the heat wasn't coming from this. The heat was coming from my dummy load. And this is where all the heat is, right here. This is quite hot back here. So you know, I'm doing both channels into a dummy load. Anyways, I don't believe this amplifier is capable of 4 ohms. They mention all their specs at 6 ohms. So, alright, so I did find a problem with the receiver. It's a minor one. It's more of an annoyance than a problem. I'll tell you what's happening here. I was going through the FM band and I was tuning the stations, and I kept hitting, I can't remember, I think it was plus or minus. I kept hitting plus, I think it was. And every time I hit the plus button, it was as if I was pushing the sound mode off button. And I couldn't figure out what was going on. I should actually hook it up and show you. Yeah, maybe I'll do that. Just give me a second. Okay, so I slapped the front panel back on and we're powered it up. And I'll show you just what it's doing. I'm tuning FM stations right now. I don't have an antenna hooked up anyways, but these are the tuning buttons for the FM. Is down. Down is working fine. Okay, now I'm going to start tuning up. And see how it says S off? It's almost as if I press that button. Now what happened here? I'll keep going up. And see, there it goes again. Now it's not going to do it. Oh, there it started. It's trying to. There. See how it's kind of freaking out? It's not consistent, and it's, you know, the receiver works. It's an annoyance. That's what, more of anything. As I tune through the band, now it doesn't. Well, it does it once in a while now. It seems like it's clearing up. But I'll show you what I think is wrong here. Okay, so there's 3 lines that tell the microprocessor which button you're pushing. They use 3 lines. Don't ask me why. You got probably 20 buttons, 30 buttons, but they only use 3 lines. So what they do is 1, 2, 3, 4, 5, 6 buttons on this line, and they're all attached to this line. That goes back to the microprocessor. Now, each switch has its own value of resistor. So what they're doing, as you press a button, you're going to switch in that value of resistance. And they're all in series too, so they add up. So the farther down the line you go, the higher the resistance gets, right? So if I push this button on the end, I'm getting the value of this resistor plus this one, this one, this one, this one, this one. And that's what the microprocessor reads. It reads the ohmic value of what is coming in on that one line. And then it knows which button was pressed, right? Now, this line here is all along here. This is the top row buttons, right? And then we have a short row of buttons here, and then another longer row of buttons here. And you'll see we have the top row of buttons is all in one line. 1, 2, 3, 4, 5, 6, 7, 8, 9 buttons. And then we have this one here that has a short row, and then it jumps over and does these 3. So this button here is the minus tuning, this one's the plus tuning, and then if I jump over here, this is the S off one, the surround off. And each resistor, for example, this one's 1.2K, this one's 1.5K, 1.8K, 2.4K, 3.3K, 4.7K, and the last one is 7.5K. So you can see there's quite a difference between your low buttons and your high buttons. Now, when I press the plus tuning button, it thinks it's hearing this button. And I think maybe this switch is dirty. Maybe it has a high resistance contact. And then the microprocessor is assuming it's this button that's being pressed. That's why it's freaking out and doing a thing. The other thing is, if you measure these resistors, they all have a tolerance. So let's measure the first one. This one's a 1.2K. And we're getting 12, 14 ohms. And then this one's a 1.5K. I think 15 and a bit, which is a little high. This one's supposed to be 1.8K. That's pretty bang on. This one here is supposed to be 2.4K. And that one's a bit high too. This one here is a 3.3. Come on. That one's a tad low. What else? 4.7 is next. That's pretty close. And then the 7.5. Which is good. Now I had a couple here that read high. I had 2 resistors I think that read high. So if I totaled up all of these resistors, I bet you it's, what is it supposed to be? 6.9, it's supposed to be around 7K. If I do the math, let me do the math and I'll get back to you. So if I do the math, the total on these first 4 resistors should be 6.9K. And I'm reading, what am I reading here? 6.96, 6.97. It's a little bit high. And I think that might be confusing the microprocessor. I think that might be one of the problems, is that the resistors, I've got a couple in there that are a bit high, and it's confusing the microprocessor as to what it's reading. And another one is that maybe the switch is gone kaput. Maybe what I could do is I could take that switch out and replace it, or swap it for one of the ones, these buttons that I don't use. Or I could just leave it alone and say to hell with it. But I'm going to pull this board out and take a look at that button. Maybe I can spray some cleaner in it. Okay, so I got the board out and looking at it. There's really nothing on the top of the board. There's no traces. But I'm looking at this switch here is the culprit. And what I'm going to do is I'm going to pull the switch out and replace it with the switch that's at the end of the line. And I think it won't stop the problem, but it'll more like mask the problem. If the switch is on the end of the line, it's less of a problem, and it will confuse the microprocessor less than it would if it was here. So what I'll do is I'll just swap these two, and just do that right now. If I can get at my iron, buried. So I did look through my parts bin, and I have push button switches like this, identical to these, but they don't have 2 connections. They have 4, and they wouldn't fit the board. Okay, that one's out. Let's take this one out. Takes a lot of heat when you got a copper ground plane like this. It doesn't want to heat up. So I'll just be more aggressive on the iron. Yeah, it really doesn't want to come out. Okay, so I don't want to mix these up. This one goes here. Let's clean up this board a little bit. Garbage desoldering braid is, I got off AliExpress. I just got to put flux on it all the time to make it work. I'm not too happy with it, but if you put a little flux on it, it works just fine. It leaves a lot of residue on the board, and that's because of the flux I put on, but whatever. A little bit of cleaning up after. good. Let's clean this up. Some alcohol. See all the residue it leaves behind? Yeah. And that stuff's conductive too. You gotta be careful. You can't leave it on the board because it'll short things out. You gotta clean it off. Okay. So this one was the near one. I need a pair of. So I'll straighten these pins. So I never intended this to be a repair, but I guess it is, in a way. I'm just going to see if this improves, and if it does, great. If it doesn't, I'm done wasting my time on this one. Because it is functioning. It's just a little bit flaky and annoying to have a button that does something it's not supposed to be doing. But we'll get it back together, we'll test it out. Okay. Solder this up. We're done. Put it back in. I'm going to clean the vacuum fluorescent display. I always clean these because they get a little bit of a fog on them. If you look at them, they get a little bit of a fog from the dust. Because they do operate at a higher voltage, you know, and that little bit of voltage collects dust, so I'm just going to clean that. So let's get paper towel. Cleaner. Glass cleaner. It's clean now. It wasn't before. And I'll also give this a wipe. The dust gets in there. That's good. Now before I bolt everything back together, what I'm going to do is I'm just going to check all these lines on the vacuum fluorescent display for cracked solder joints, and there's a couple connectors here. I'm just going to check those over. You don't have to watch. Alright, so we're all back together now. I just want to try it out one more time. Doesn't seem to be doing it anymore. The tone button is working. Yes, off. Yeah, I think it's cured now. It doesn't have any more weirdness. It's not doing it anymore. That's good. Okay, I think it's the result. The other buttons are working. Oh, that one was a little flaky. These three buttons are having problems. See? I'm not going to worry about those. Once you set it up to the mode you want, the surround mode or the surround sound off, you just usually end up leaving it there like that anyway, so I'm just going to leave that alone. But it's working good now. Alright, so what do you think about maybe doing a 1,000 subscriber lottery for this? I don't know, I think it might be a good idea. Give this away to somebody that could use it. Get some nice little Pioneer stereo. Let me know in the comments what you think. Alright, thanks for watching.